Good morning, students. Welcome to another class, another mathematics class with Mr. Victor Egenkonye. And in today's class, we'll be studying probability, which is primarily for the SS2 students, but secondarily for other senior classes. So, alright, in today's class, the objectives for this class is, at the end of this lesson, what you're expected to learn is you should be able to use the language of probability, describe and evaluate events involving chance, and also you should be able to use theoretical probabilities to calculate problems involving chance. And lastly, you should be able to solve problems involving combined probabilities, particularly those relating to mutually exclusive events and or independent events. Now, in our world today, you can see that everything happens by chance. Many events can be predicted with total certainty. And the best way we can say is how likely they are to happen, because things don't just happen anyhow, they happen by chance. So we can't just say rain has to fall today. It may or may not fall. So they happen by chance. So using the idea of probability, we are going to see how to evaluate, how to measure the likelihood of something or of an event to happen. Now, sometimes we can use words such as impossible, unlikely, possible, even chance, likely, and certain. Now, you can say, it's impossible for me to go to Jane's house. Now, that's a likelihood of something to happen. It wouldn't happen. That's why you're using the word impossible. Or you can say unlikely. And also, if you are so sure, you can say it's possible that I will go to Jane's house. Now, all these are likelihood, are chance events. So, for example, we can also say it is unlikely to rain tomorrow. That means we are not sure. We are not sure that it may rain or it may not rain. So, let's take a little definition of probability, which says that probability is a measure. I want you to underline that word, measure. The word you have there, measure. Probability is a measure of the likelihood of an event happening. So what we'll be doing is to measure that likelihood of that event happening, which we'll say the formula to use, the mathematical formula to use. Now, if you look at what you have on your screen now, we all know what coins are, and we know that a coin has two sides, which we literally call the heads and the tail. From the picture you have there, you can see a head of a president there. That's what we refer to as the head, and the other side of the coin is referred to as the tail. Now, when a coin is tossed, there are only two possible outcomes when you toss a coin. Either the head appears or the tail appears. So we say that the probability of the coin landing on its head is 1/2. Now, why is it 1/2? Because the possible outcome is only one. Either the head appears or the tail appears. So there's only one possibility of either a head appearing or a tail appearing, and the total possible outcome we have is 2, because the coin has two sides. So we say the probability of the coin landing on its head is 1/2, and probability of landing on its tail is also 1/2. Now let's look at throwing a die. Now, when you have a die, in the picture you have dice, that two dice. Now, when you throw a single die, for example, now if you remember, a die has 6 faces, which are numbered from 1 to 6. One of the faces has a number 1 on it, 2, the next, another face 2, another face 3, and so on, up to when you get to 6. Now, the probability of any of them appearing, definitely you know that when you toss a die, only one side can appear at a time, only one face can appear at a time. So the probability of one of the numbers appearing or one of the faces appearing is 1/6. Why? Because there is only one possible face appearing, but there are 6 total outcomes. Now, in the next slide, you see the probability in general, where we have the mathematical expression, and we define probability of an event happening as number of ways it can happen over total number of outcomes. Now, taking us back to the previous slide, you can see that when we toss a coin, the number of ways it can happen is 1. There is only one possibility of that coin appearing, either on the head or on the tail. So the number of ways it can appear is 1. Then the total number of outcomes is 2, because we have two faces on a die, on a coin rather. Because we have two faces on a coin. Now let's take another example. The chances of rolling a 4 with a die. Now if we wish to toss a die and we wish for a 4 to appear on that die, now taking the formula, the number of ways it can happen is 1. Why? Because there's only one face with a 4 on it. And the total number of outcomes we have is 6, because there are 6 faces altogether. So the probability can be defined as 1 over 6. Using the formula which says that probability of an event happening is number of ways it can happen over total number of outcomes. Now number of ways it can happen is 1. You can only have, there's only one face with number 4 on it. That's why the number of ways it can happen is 1. And then there are 6 faces on that die. That means total number of outcomes is 6. So the probability there is 1 over 6. Now there are some definitions we need to consider before we go further in this lesson, and which we have experiments. Experiments can be defined as a repeatable procedure with a set of possible results. Now in our objectives we talked about theoretical probability. We also have what we call experimental probability, which makes use of repeating a procedure and recording your results. Now such method of calculating probability are not too feasible today, because they can't really predict the future. For example, if I toss a die for, let's say, 10 times, the outcome I will get in tossing that coin 10 times and tossing the coin again, let's say in the next 10 procedures, I'll have different results from two different experiments. So you can see that it can't give you a genuine result or a genuine certainty of what the future can entail. So that's why we always use theoretical probability. So moving to the next definition, we have outcome, which we've discussed previously. That outcome is a possible result of an experiment, just like tossing a coin. For a head to appear, that's an outcome, is a possible result. So that's what we refer to as outcome. Then we'll move to sample space. Sample space talks about all the possible outcomes of an experiment. Now you have your coin. What are the faces we have on the coin? The head and the tail. So that's our sample space, because that's the total possible outcomes you can have in that experiment when we toss the coin. So we'll move to the sample points. Now, sample space is made up of sample points, and sample points is defined as just one of the possible outcomes. So if I have my sample space as the head and tail, that's the total possible outcomes I will have. Then just picking a head is a sample point, or just taking a tail is a sample point as well. Then event is defined as one or more outcomes of an experiment. For example, getting a tail when tossing a coin, rolling a 5 on a die, rolling an even number. We know even numbers. Even numbers that exist in the die are 2, 4, or 6. So those are examples of events. Now we can use notations to define probability. We can see what it looks like using notation to describe the mathematical expression of probability. Now if there are n possible outcomes and r required outcomes, the probability P of obtaining a required outcome is given as a fraction, which you have on your screen there. Probability P equals number of required outcomes over number of possible outcomes. So using the notations, we can write the probability as R over N. Now in set notation, I believe you've learned sets theory in your SS1. We can define this probability as P of R equals cardinality of R over cardinality of S, where P of R is the probability of a required outcome happening, and R is the required outcome. So the cardinality there tells us that we'll count the number of required outcomes in that set. That gives us the number of required outcomes, which we'll insert in our formula. And S equals all possible outcomes. Now you should note that the probability P may be a common fraction, which we've seen before, a decimal fraction, or a percentage, which we'll see in our next example. So taking our example 1, now if I have 4 pens in my desk drawer, which are red, green, blue, and pink, if I draw a pen, now just imagine it, you have a drawer in your room, and there are 4 pens there in it, and they have the colors of red, green, blue, and pink. Now if you dip your hand into that drawer without looking, there's a probability that you can pick any of those 4 pens, and you do not know which of the pens you pick. It could be red, it could be green, it could be blue, it could be pink. Now that tells you that each pen has the same chance of being selected. So in this case, what will be our sample space? Remember, we define sample space as the total possible outcome. So our sample space in this case will be the red pen, the green pen, the blue pen, and the pink pen. That gives our sample space. And the chances of drawing a green pen, for instance, let's assume that we want to draw a green pen. So the chances of drawing a green pen, we have to get the number of ways it can happen. In how many ways can we draw a green pen? There's only one way we can draw a green pen. When you dip your hand in that drawer of yours, there's only way you can pick a green pen by chance. Remember I said earlier that probability is all about chance. So the number of ways it can happen is what? 1. There's only 1 green pen in my desk drawer. That's why the number of ways it can happen is 1. Then total number of outcomes, which we just defined earlier, the sample space, total number of outcomes there is 4, because there are 4 pens in my desk drawer. So what will now be our probability? Now going back to our definition of probability, where we say that probability is defined as the cardinality of the required outcome, which is highlighted now. The probability of the required outcome. Now the required outcome we have there is 1, because there's only 1 green pen in that drawer. That's why you have the probability there as 1. Then the cardinality of the possible outcomes, you check, how many pens do you have in your drawer? That will give you the cardinality, which is our sample space. Now there are 4 pens in the drawer. So the probability, using the definition of picking a green pen, will be 1/4. Now, if you look at what we talked about earlier, that probability can be a common fraction, a decimal fraction, or a percentage. So the probability which we just solved now as 1/4 can also be written as a decimal, which is 0.25. So what you should understand here is that, first of all, you need to know what your sample space is, the total number of outcomes you have in that experiment. Then also, you need to know the probability of that particular event you wish to calculate, and then get the number of ways it can happen, divided by the total number of outcomes, which is your sample space. So moving on to the next example, which says a coin is tossed once. Now take note of that. Coin is tossed once. It can be tossed twice, thrice, or more. Now a coin is tossed once. We have to find probability of getting a head. And like I said earlier on, we have to know the number of ways it can happen. Remember, our bone of contention here is getting a head. Now when we toss that coin once, a head should appear by chance. So number of ways it can happen is 1, because there's only 1 head in a two-sided coin. And total number of outcomes is 2. There are only 2 sides in the coin, the head and the tail. So what will be our probability? The probability of picking, of getting a head will now be the cardinality of heads over cardinality of the sample space. And number of heads we have is 1. We only have 1 head in a two-sided coin, all over the total number of sides we have in the coin, which is 2. So our probability of picking a head is 1/2, which can also be written as 0.5. Now, for what we've discussed so far, there are some observations we've made, which is shown on that picture you have on your screen there. So we can show probability on what we call a probability line. Excuse me. So you can see that when we say probability of an event happening is 0, that means that event can never happen. It's impossible. So every probability is a number between 0 and 1. where 0 means that event can never and will never happen. And when the probability is 1, we say that event is certain to happen. That event is certain to happen. Just like saying the morning will come. Definitely we can't be, the day cannot just run from afternoon to evening. We have to get to morning too. So it's a certain event. And also an event that will never occur has probability of 0, which we've mentioned earlier. An event that is certain to occur has probability of 1. Then when there's an even chance, let's say it may happen, it may not happen, we call it an even chance. That's between 0 and 4, at the middle there, 0.5. Now, if the probability of an event, this is very important, if the probability of an event happening, of an event A happening is P of A, then the probability of the event not happening, as negation, is 1 minus P of A. We'll see this in subsequent examples. Now, moving on to example 3. Now, Jessica throws a first 6-sided die. With what is the probability that she throws A 9, B a 4, C a number greater than 2, and D an even number? So let's start with the first question there. What's the probability that she throws a 9? Now, before we take this question, let's go back to our chart. Now, you can see that the probability of an event that will never occur is what? Is 0. That means if an event cannot occur, we say the probability is 0. Now, moving back to our example, we're asked to find the probability that she throws a 9. Now, remember, she's trying to throw, she's throwing a 6-sided die. That means on that die, there are 6 faces, numbered 1 to 6. So if she wants to throw a 9, how do we explain this? That means there's no possibility of doing that, because there's no 9 on that die. Since the faces of a 6-sided die are numbered 1 to 6, it is impossible to throw a 9. So we simply say the probability is 0, because there's no 9 on a die, on a 6-sided die. So moving on to the next question there. What's the probability that she throws a 4? Now, there's a chance of throwing a 4, definitely, because the die is numbered 1 to 6. And it can happen in only one way, because there's only one face of that die that has a 4 on it. So the probability, which we define as number of ways it can happen over number of outcomes. So number of ways it can happen is 1, and number of outcomes is 6. So the probability of Jessica throwing a 4 is 1 over 6. So the probability, the next question there is probability that she throws a number greater than 2. Now, remember what we talked about when we learned inequalities. Where we talked about the greater than, the less than, strictly greater than or equal to, and all that. Now, you can see from here, the question asks us to find the probability that she throws a number greater than 2. But before we get the probability, we have to understand that there are 4 possibilities that are greater than 2. Now, since the question says it's greater than 2, the question never stated that it's greater than or equal to 2. That means it's strictly greater than 2. So the numbers that are strictly greater than 2 are what? 3, 4, 5, and 6. So there are 4 possibilities. So the probability, which is number of required outcomes over number of possible ways. So the number of ways she can throw a number greater than 2 are how many? Now let's count. We have 3, we have 4, we have 5, and we have 6. So number of ways she can throw a number greater than 2 are 4. That's 3, 4, 5, and 6. They're 4 in number. Then the number of possible outcomes is 6. Why? Because our sample space is 6. A die has 6 faces on it. So the probability equals 4 over 6, which can be reduced to 2 over 4. And like I said earlier on, you can still write this as a fraction, as a decimal, or as a percentage. So moving on to the last question there, which says what's the probability that she throws an even number? Now, just like the technique we used in getting our outcomes from the previous question, there are three possible even numbers in a six-sided die, which are 2, 4, and 6. So number of required outcomes will be 3, because there are only 3 possible outcomes there. Then the total number of possible outcomes is 6, just from our sample space. So the probability of Jessica throwing even numbers is 3/6, which is reduced to 1/2, or can be written as 0.5. Now let's move to another part of probability, which is stated in our objectives: mutually exclusive events. Now, what are mutually exclusive events? Suppose A and B are 2 events in a given situation. If A and B, underline that word cannot possibly occur simultaneously, they are said to be mutually exclusive events. Now, if there are 2 events that cannot occur simultaneously, for example, if I toss a die once, is there any possibility that a 2 will appear and at the same time a 3 will appear? No. So these events cannot possibly occur simultaneously at the same time. So such events are what we term as mutually exclusive events. So for mutually exclusive events, the probability that one event or the other occurs is given by probability of A or B equals probability of A plus probability of B, which is also known, this is also known as the addition law for mutually exclusive events. Now, moving on to example 4, we'll see how to apply this law. Now, the example here states that one ball is drawn from a bag containing 3 white, 4 red, and 5 black balls. What is the probability A that it is white? Now, remember the question says one ball is drawn, so I have to take note of that. One ball is drawn from a bag containing 3 white, 4 red, and 5 black balls. Now, what is the probability that it is white, or red, that it is not red? Now, A. Firstly, we have to get our sample space. Our sample space consists of what? All the possible outcomes. And from what we have here, we have 3 white balls, 4 red balls, and 5 black balls. So our sample space will be a combination of all these balls, which in total is 12, as the cardinality of the sample space is 12. So now, going to the first question there, now what's the probability that it is a white ball? That when the individual draws one ball from a bag, that it's going to be a white ball. Now, there are 3 white balls, so therefore our required outcomes is 3. Or the number of ways of picking white balls is 3. So the probability of picking a white ball equals cardinality of white balls over cardinality of the sample space. Now the required outcome equals 3, and the total outcome is 12. So the probability of picking a white ball equals 3/12, which can be reduced as 1/4. I believe that's understood. Then moving on to the next question. Now the question says, what's the probability that it is white or red? So can you see that these events are mutually exclusive? Because if one ball is to be drawn, then I wonder how 2 balls will come out at the same time. So definitely, it's a mutually exclusive event. They cannot happen at the same time. So it's either the individual is picking a white ball or a red ball. So from our formula, which we have it as P of A or B equals P of A plus B. So now, first of all, we have to get the probability of picking a white ball, and then taking the probability of picking a red ball before combining such probabilities using the addition law. So what's the probability of picking a white ball? We've seen that in our previous example, which is the which is the number of white balls, the cardinality of white balls over the cardinality of the sample space. And you have 3 white balls in that bag. So the probability equals 3 over 12. And the probability of picking a red ball, how many red balls do we have? We have 4 red balls in that bag and a total of 12 balls. So probability equals number of red balls over total number of balls, which is 4 over 12. So now I've gotten the probability of picking a white ball. I've gotten the probability of picking a red ball. So the probability of either drawing a white or red ball is given as, remember our formula, which is the addition law. Probability of picking of white or red equals probability of white plus probability of red. So combining these two probabilities, this gives 3 all over 12, which is the probability of picking a white ball plus probability of picking a red ball, which is 4 over 12. So adding these probabilities, our result is going to be 7 over 12, taking the LCM and doing the arithmetic there. So the probability of picking a white or red ball is 7 over 12. You can change this in percentage to see the likelihood of that event happening. So looking at the next question, which is the last, there was a probability that it is not red. Now I want you to quickly, let's go back to our chart where we have that if the probability of an event A happening is P of A, then the probability of the event not happening is 1 minus probability 1 minus P of A, that is 1 minus probability of that event happening. So quickly, going to our example, we're asked to find the probability that the individual is not going to pick a red ball. So first of all, we have to get the probability of picking a red ball. And probability of picking a red ball is number of red balls over total number of balls, which is 4 over 12, which can be reduced to 1 over 3, which we saw in our previous example. Then going to the main question, which says the probability of not picking a red ball. So probability of not picking a red ball is going to be 1 minus probability of picking a red ball. And probability of picking a red ball is 1 over 3. That means probability of not red equals 1 minus 1 over 3, which is subtract to have 2 over 3. So probability of not picking a red ball is 2 over 3. So the main thing here is that when you're asked to find the probability of an event not happening, you first of all get the probability of that event happening, then subtract it from 1. Now you need to note that using the addition law to solve problems, we can use the additional law to solve problems that involves words such as or either, or. When they say find probability of picking either a rose flower or another type of flower. So in such cases, you use the addition law. And in cases such as the example above, we add the separate probabilities to give the combined probability. So what we saw here was that first of all, we got the probability of picking the white ball. Then we went ahead to find the probability of picking a red ball before adding the separate probabilities to get the combined probabilities as 7 over 2. So that's what you should note there. Then also, another side or twist to the addition law. Now, if two events are not mutually exclusive, that is, they can take place at the same time, then the probability of at least one of the events occurring is given by P of probability of A or B equals probability of A plus probability of B minus probability of A and B. And this is termed the general addition law. We shall look into this in our next class. Now, moving on to independent events. Now, if two events A and B are said to be independent, that is, if the occurrence of the first event has no effects, on whether or not the second event occurs. Now, before we go further, let me explain what that means. Now, for example, I have a coin on my left hand and I also have a die on my right hand. If I toss the coin and throw the die, Now, these two events can happen simultaneously. The coin can be tossed and the die can also be thrown. You can see that the possibility of this event happening has no effect on the other event. So such events are what we call independent events. Now, for independent events, the probability that one event and the other occurs is given by probability of A and B. So you can see there's a combination here now, as in contrast to the previous law, which adds probability of A and B equals probability of A multiplied by probability of B. And this is what we call the multiplication law for independent events. Now, in our next example, we'll address that. Example 7. If a red die and blue die are thrown, what is the probability of getting a 2 on the red die and a 3 on the blue die? So you can see that there are two events here. Like the example I gave you earlier on, we have a red die and a blue die, two different dies. So I can decide to have a red die on my left hand and a blue die on my right hand. So what's the probability that 2 will appear or will surface on the red die, and you see that word "and" there. Whenever you see the word "and" there, that tells you that you're going to use the multiplication law. And a 3 on the blue die. So just like what we did in our previous example on law, first of all, we have to get the individual probabilities, the separate probabilities. So firstly, okay, we can combine this in the formula. These events are independent because they're independent. They can happen at the same time. The red die doesn't have an effect on the blue die. So probability of getting a 2 on the red die and 3 on the blue die is defined as the probability of 2 on red multiplied by the probability of 3 on blue. Now, probability of getting a 2 on red. Now, in how many ways can we get a 2 on a die? There is only one phase that has 2 on it, so there's only a way that we can get a 2 on a die. So the probability there is 1 over 6. The 6 there tells you that is the sample space. There are 6 faces on the die. Multiplied by, now how do you get a 3 on the blue die? There's also one phase that has 3 on it. That means there's only one possible way of getting a 3 on that die. All over 6, which is our sample space. So multiplying this should give 1 over 36. 36. When you multiply the numerator, you have 1. And when you multiply the denominator, you have 36. Alright, you should note that use the product law to solve problems that contain the words and, or, both, and. So when you see these words and, or, you see the word both and combined in a sentence, then that tells you that you should use the product law. Now, in such cases as the example above, multiply separate probabilities to give the combined probability, as we've seen earlier. So I believe you understood or got the graphs of this lesson. If you have questions, you can send your questions through the available platforms you have. And for your assignments, which you are seeing on your screen there are 3 questions there. Solve your assignments and submit to the number which will be sent to you. Alright, thank you for watching. Do have a pleasant day ahead. Thank you.